All right, real world problems. A fundraising dinner was held on 2 consecutive nights. On the first night, 100 adult tickets were sold and 175 children tickets were sold. Okay, for a total of $937.50. On the second night, 200 adult tickets were sold and 316 children's tickets were sold for a total of $1,790. Find the price of each type of ticket. Okay. First off, for those of you at home, sweet, sweet Carlton shirt. You're missing it. All right. Don't worry. I have many more. Many more. There's like 6. All right. Nikki Grantling, give me 2 good variables to represent adults and children. A and C, I agree. A and C is going to be very helpful in allowing me to keep my work and my answers kind of, I guess, aligned. Okay? If I use X and Y, which I could, which is more accustomed to what Lance has probably worked with in the past, right? The problem becomes, well, when you get X equals a number, did X represent adults or did it represent children? You know what I'm saying? But if I get A equals something, it's going to be very easy. And the way I typically work is I just write it alphabetically, right? So here, 100 adult tickets plus 175 children's tickets. And I made $937.50. See where that came from, Lance? Pretty easy, right? Equation number 2, you give it to me. Very good. Now the question becomes, how do I solve this? Julia, how would you solve this? Because this is good for the test, okay? There's not a wrong answer. Let me start out with that. There's not a wrong answer, okay? There's a easier answer, but no matter what you do, you're going to get like an answer, okay? Okay, you would use substitution. All right, why would you use substitution?
That would be algebra, and there's nothing like corresponding correlation.
Okay, so Julia said, we ain't graphing this because the numbers are too big. And you're right, you could graph it, right? But you're gonna spend a lot of time zooming out, rearranging and relocating your graph. And it's just not gonna work out for you. So Julia, you said substitution, okay? Sounds good, let's do substitution, all right? So with substitution, all right, with substitution, I need to get an equation, or I need to pick an equation and then get a variable by itself. So Julia, which variable would you like to isolate? In which one, the blue or green? All right, so let's get A by itself. So first thing I'm going to do, all right, since you choose that one. Let me rearrange this. Get rid of that. This one back over here. All right. I'll bring that back into play later. So you said let's get A by itself. So I'm going to go ahead and subtract 316C from both sides. These cancel. So I have 200A equals negative 316C plus 1790. Are you okay with that, Julia? And then you divide everything by 200, right? And you get A equals, let's see, that's going to be 158. So negative 1.58. Did I get that right? So negative 1.58 C, and then this is going to be plus, those cancel. 20 would be 8.95. All right. So I got that. Now you are going to take this equation, right? And you're going to plug this in for A. So we have 100 times negative 1.58A plus 8.95. Not A, that's the C. My bad. Plus 175C equals, losing the color coding. Today it's a rough day. Eagles lost. And right, words not aligned. All right, so I have 100 times the quantity of negative 1.58C plus 895 plus 175C equals $937.50. You okay with that? We're going to distribute this out, so we're going to get negative 158C plus 895 plus 175C equals 93750. So all I'm doing right now is just multiplying stuff out, distributing it, and combining like terms. Are you okay with that, Lance? You following along? You lying to me? All right. So Lance, did you follow me to here? Oh, okay. You hold on. You keep doing elimination. Okay, you do you. All right. So here. Now I'm going to combine my C's. Okay. So 175 minus 158. I'm feeling it's 17. So 17C plus 895 equals 937.50. Now I'm going to subtract that 895 off. That's going to give me 17C equals 42.50. I was surprised I got that. And then divide by 17. And Lance, did you finish the problem? Did you get, don't tell me. Did you get kids cost is 250? So I got the kids cost is 250. Now I plug it back into this. So if I took C for 250 and plugged it back into A, all right, I would get A equals, don't tell me, I want to get this on my own. So that's going to be 316. Is that going to be 316 plus 79? So it's 95 to 95. Oh, is it $5?
Mr. Harmon, I have a question.
Yes, Jake.
Why did you choose to use substitution for that when?
I didn't. Julia did.
But elimination would be a lot faster for that.
Okay, and that is true. So that's how to do the problem using substitution. Julia, How do you feel with that? Good? Lance, you said you did it a different way, right? Lance, which way did you do it? Elimination. All right, so I always said there's not a wrong way, there's just an easier way. Okay? Has everybody got this down? It's a lot of work, right? But we got it. Okay? Here we go. And Julia, you can take it or leave it. Okay? You can do these problems however you want. But my advice is to teach you how to do them in like all different ways. And then I basically hand you the tools and then you figure it out. Okay? So here's what we got, Julie. We have 100A plus 175C equals 937.50. Okay? And then we have 200A plus 316C equals 1790. Right? Here are my rules. My rules are as follows. If my variables are on the same side, chances are I'm doing elimination because they're lined up. I can multiply one equation by something, or I can multiply both equations to make my variables go up. Okay? That's what I do. Now, if one variable I could get by itself like really quick, I might choose to do a substitution. The only time I do substitution is when one of the variables is completely solved for. Okay, in graphing, I only ever graph if it's in like y equals mx plus b and they're like real small numbers. Otherwise, I don't do it. So here's a different way to do this problem, Julia. Do you see how the A's are lined up and the C's are lined up and then your number? Well, do you see 100? Can't you make 100 200 by just multiplying it by 2? So if I multiply this by 2, I'm not going to do the whole problem. Okay? I got, oops, I didn't work out the I have 2 times 100 is 200 plus 2 times 175, that's 350. 2 times 937.50, 18, 75. Is that what you did? Is that what you got? Now, do you see how the A's are lined up? I subtract, get rid of my A's. And that's going to give me 34C equals $85. And then you can divide it out from there. Okay, but you weren't wrong, right? Just sometimes there's just an easier way. Now, why am I bringing this up to you? On the test, okay, on the test on Wednesday, there is a section. You have 2 of each problem. It's going to say solve by graphing, and you will have to graph. If you don't graph, you get it wrong. I don't care if you got the right answer. You will get it wrong if you don't graph. And you have to upload the work, okay, that corresponds to it. There are going to be 2 where you have to do substitution. So you seem like you mastered substitution, right? Then there's going to be 2 where I say you have to do elimination. There are, I believe, 3 problems at the end that say solve however you want. And that's when you could do substitution and you could do elimination and you could do graphing. Okay? And you'll all get the same answer and you'll all get the credit if you get it right. But the thing is I'm trying to set it up so you look at it and you say like, oh, I should just do elimination for this. It's just going to be that much easier. Or, hey, I should do substitution because my life's going to be better. All right?
I had a question.
I have an answer, Jake.
Wait, on that last problem, the problem you just did when you did elimination, when when you were doing the x part, you subtracted those two.
Yes.
But why did you subtract them? Wouldn't you add them?
No, because they were the same subtract.
So when do you add?
When they're opposites.
Wait, that's different than what we do.
No, check the notes. It's in 4.2. You can watch it. It's on YouTube. All right, 10 pounds of mixed birdseed sells for $6.97 a pound. Kind of sounds familiar, right? Not like a problem in the web assignment. So it says the total. Well, what's the total? If I have 10 pounds at $6.97 a pound, Chris, what would I do with those two numbers? Multiply. So 10 times 697 is 6970. So it says the mixture is obtained from two kinds of birdseed. What do we want to call that birdseed, Chris? A and B?
Yeah.
Sounds great. With one variety priced at $5.65 per pound and the other at $8.95 per pound. How many pounds of each variety of birdseed are used in the mixture? So we know we have 10 pounds. So A plus B equals 10. Chris, what's the other equation? How much is the first birdseed? 565. How much is the second one?
895.
What's 895 big? Equals 6970. Now, Julia, to your defense, this one, see how I could get A or B by itself? Even though I could do what Jake said with elimination, I could just multiply it by 565 and then get rid of it. To me, it's like half a dozen, one way, six of another. Right? So for this one, I would probably do substitution. I would say A plus B equals 10. So A equals 10 minus B. Okay? And then I would just take that and I would just go ahead and plug that in for A. And I would get 565 times 10 minus A plus 10 minus B. Off my game today, Nikki Grantland. I can crunch numbers in my head today. Plus 895B equals 6970. Now what would I do, Chris? Yeah. So you're going to get 5650 minus 565B plus 895B equals 6970. So I'm going to go ahead and combine my B's in the middle there. So I have 5650 plus 330B equals 6970. Subtract the 5650, you get 330B equals 1320. And then I get B equals 4. Once I get B is 4, 10 minus 4, 1/6. I like these problems. They're good SAT problems. Anybody signed up for the SATs this year? No? No, you probably wouldn't have. Chris, you signed up? Thinking about it for the spring? I think you should take it once your junior year. the end of your junior year? Required? No, nothing's required. Showing up to school, not required. Strongly recommended. All right, let's skip number 3. Let's go to number 4. All right. Ooh, airplanes flying into the headwind. You remember that problem? Julie remembers it. You didn't? Did you do it? Probably not. All right. Who do I want to pick on? Lance, who should I call? I got Hansi.
Yeah.
It's his birthday yesterday.
Hansi, Mark says hello.
Hi, Mark.
Mark Hansi says, what are you doing with this answer? I mean, like being festive. Probably would.
I would.
I didn't know it was a jokester. All right. An airplane flying into a headwind, Hansi, travels 1,800 miles in 3 hours and 36 minutes. On the return flight, the same distance is traveled in 3 hours. Find the speed of the airplane in still air and the speed of the plane, or the speed of the wind, assuming both remain constant throughout the rest. All right, ready, Hansi?
Yeah.
Hansi,
Yeah.
what is this? What is that, Hansi?
It's a plane.
Plane. It's a darn good plane, too. Okay?
Yeah, it's a solid plane.
Headwind, meaning wind is going this way. So the plane's going to be slower, right, Hansi?
Yes.
Okay. The plane goes 1,800 miles in 3 hours and 36 minutes. Here's the thing, Hansi. I don't like 36 minutes. 36 minutes is what of like an hour. So I want that as like a decimal. So 3 hours and what?
0.36.
Really? Did you really just say that? That's going to be on YouTube.
I did.
I hope those shoe collectors don't listen into this. Hansi, how many minutes are in an hour?
60.
So it's 36 divided by 60.
Point 0.6.
0.6. So instead of writing 3 hours and 36 minutes, I want you to write 3.6 hours. Now, we know this equation. E equals RT, right? Where distance equals rate times time. Agreed? So the plane is traveling this way at some rate. The wind is traveling this way at some rate. The distance we know is 1,800. The rates, well, the plane is flying into the wind. Okay? So since it's flying into the wind, it's going to slow it down. So I have to do P minus W. Now times T, which is, thanks to Hansi, 3.6. Now, Hansi, I hope you're drawing these pictures, Hansi.
I am.
Now, Hansi, on the way home, it only takes me 3 hours. Don't worry, I won't ask you that as a decimal. But Hansi, we have the same formula, distance equals rate times time. Okay? The distance is 1,800 miles. 1,800 miles, Hansi. Now the rate this time is the plane plus the wind. And it travels that in 3 hours. I think Granlund's like, where are you going to go from here, Harmon? Watch this. I don't like this part here, do I? How do you get rid of times 3.6? Divide. So I'm going to do 1,800 divided by 3.6. Don't tell me. Oof. That's what? 36 over 10? With like 500? So this is going to be 500 equals P minus W. So I'm going to write that over here. 500 equals P minus W. Don't worry, I can do this one. Divide by 3. This gives me 600 equals P plus W. Jake, what method am I going to use?
You're gonna use. So, oh wait, for this one you can use graphing. Wait, no, you can't. You can't. You can use elimination.
Elimination, because I want to get rid of the W's. So they're opposites, so I'm going to add. So I get 1,100 equals 2P. It's 550 equals P. So my plane is traveling at 550 miles per hour, which makes sense, right? That's like a logical answer for a plane. Now the wind, well, if we look up here in my green equation, 500 must equal the speed of the plane minus that of the wind. So 550 minus what is 500? And that's 50 miles per hour. So there we go. Ooh, these are good questions. And that is that.